Okay, this lesson is on distance time graphs, where we're actually going to be graphing motion. Okay, so plotting distance against time can tell you a lot about the journey that whatever the object is taking. Whenever we're looking at these graphs, know that time always runs horizontally. That arrow that you see here in the blue shows the direction of the time. The farther to the right that you go means the longer time it is from the start, which, remember, time is always moving, and we'll get into that in a minute. Okay, so distance is going to be the opposite line here, and it's going to run vertically. So same thing with time, the farther you go, and this time the farther you go up, the farther distance you are from the start. Okay, so let's first talk about what the graph is going to look like if something is not moving. So, when something is not moving, time is still increasing. Time is always going. It's going now. So it's going to increase to the right. But the distance is not going to change. So if it's not moving, the distance is going to stay the same. So, for example, let's talk about an object which is stopped at 30 meters from the starting point. So starting point would be 0. So we're going to plot up the distance at 30 meters. So there it is on the graph. So if it is stopped when we start timing at the time 0, it's going to be at 30 meters. So that's where we are from the starting time. Now, after 2 seconds, if it is not moving, it will still be at 30 meters. Well, guess what? After 6 seconds, if it is not moving, the distance is going to stay the same, but time is always moving. So it'll be the same thing after 14 seconds. So, what you need to know is when a graph, if something is stopped, it is not in motion, you will see a horizontal line. Make sure you know that. Okay, so now let's talk about an object moving at a steady speed. It's not slowing down, it's not speeding up, but it's kind of staying the same speed. So for example, you can say you're driving and your parents got it on cruise control. Say they're going 60 miles per hour. That would be an example of a steady speed. But the example we're going to look at in this graph, let's say that the object is going 3 meters per second. So after 1 second, it will have moved a distance of 3 meters. 3 meters per 1 second. So there's our point on our graph. After 2 seconds, so if it's 3 meters per second, what would it be after 2 seconds? That's right, it will be at a distance of 6 meters. Alright, so let's now think about 4. 3 meters per second, if there's 4 seconds, you are correct. It is at a distance of 12 meters. So what you're doing, if it's 3 meters per second, remember that word per means multiply. So you would say 3 times the amount of seconds. So in this case, after 8 seconds, 3 times 8 is going to be at a distance of 24 meters. After 12, 12 times 3, 36 meters. So if you notice, there's a trend in the graph. So the graph of an object that is moving at a constant speed is going to be a diagonal line. It's going to be a straight diagonal line. Now, another thing you need to know is that both of these lines show that the object moved the same distance. Okay, so they're both at 35, around 35, or I guess it will be 36 meters. But what is the difference here? This one here, the blue line, we stopped at 12 seconds, but the red line appears to have stopped in half the time. So what you need to know is the steeper one is going to be the one that got there first, so it must have traveled faster. So the steeper the line, the faster the object's going to be traveling. Another thing you need to note. Alright, so now let's look at if the object is accelerating. Now accelerating can mean speeding up or slowing down, but I am going to give you another word that you can say for slowing down. Okay, so accelerating, speeding up, this is what that graph is going to look like. It's going to start kind of like this, and then the line is going to become steeper. So that means it is getting faster. Okay, so the line is curving upwards. This shows an increase in speed since the gradient is getting steeper. Remember, the steeper the line, the faster it's going. Okay, so now I told you accelerating can mean speeding up or slowing down. But another word for slowing down, and you'll see it often, is deceleration. So it's going to be backwards. It's going to be steeper and then become less steep. So in summary, you need to know these. If the line is horizontal, that means that it is stopped. If the line is diagonal, that means it is going at a constant speed. If you see a line that is getting steeper or becoming less steep, it is accelerating. Now, you are going to see some graphs that are a combination of these. We'll get into that a little bit later in the lesson.